Okay, this is an example where we're going to compute the volume of a runoff hydrograph in equivalent units of depth or rainfall depth. And so what I've got here is I've shown you that basically if you take the hydrograph here and you have discrete values of the discharge, if we take the, basically small little rectangles times each delta t, so the value of the discharge, the discrete value times delta t, if we sum those up, we get the volume up underneath this hydrograph here, and it's not showing up on this slide that I've embedded, but this is the equation that you would have here, is that the volume is the sum of each one of these little rectangles, and that's the qi times delta t. So what we're going to do is we're going to work a problem and look at how we might have a hydrograph. And so I've got various units in half-hour time steps. And so I've got in the first half-hour time step, so this is a time, so 0, 0.5, 1.0, 1.5, 2.0, 2.5. These are all in hours, 3.0, 3.5, 4.0. Let's go to that. And so I've got Q values of direct runoff that start off here at 428. So 0, 428, 19, 23, 52, 97. These are all units of cubic feet per second. 91. So let's run this together here. 9131, and we've got 10,625, 7,834, 30, 39, 21, 18, 46, then 4.5, 5.0, 5.5. So this is 1402, 830. 313 and back to 0, 6 hours. So this is a runoff hydrograph. So you can think of this as being this illustration on the right. Now, if I want the volume under here, I could multiply each one of these values of discharge. This would be QI, and I've got this nomenclature here. I can multiply those by the delta T of 0.5 hours. And I could get that, and then I could sum them up. Now, if delta T is constant, I can pull that. So let's just write that down here. Sum QI delta T. Because this is a constant, I can pull this through the summation sign. And say that that's delta T times the sum of QI, right? So what I'm going to do is I'm going to sum these up. I'm going to sum this entire column up. And I end up getting a value of 43,550. And so in order to get the volume in cubic feet, I'm going to have to take that and multiply the delta T. And then the delta T here is half an hour. So I've got 0.5 hours, but I've got cubic feet per second as my units, and I want the volume in cubic feet. I need to figure out what that is. So there's 1,800 seconds in 1 hour. There's 3,600 seconds in 1 hour, and so my delta T is going to be 1,800 seconds long. So I'm going to multiply that. So the volume then becomes 1,800 seconds times 43,550, and I end up getting a total volume. Let's see, looks like 7,839 cubic feet. So 78,390,000 cubic feet. Now, that's not what I'm after in terms of the final answer. I want the equivalent volume in depth of rain. Okay. And so what I'm going to have to do there in order to get that, and we're going to call that R sub D, I'm going to have to take that volume of rain or runoff and divide that by the drainage area. Now for this particular problem, the drainage area is equal to 7.03 square miles. I can convert that by multiplying. There's 5,280 feet in a mile. So if I square that, that gives me square feet in a mile, in a square mile. That ends up being 195,985,152 square feet in this drainage area. So if I take that volume, 78,390 cubic feet, divided by my drainage area of 195,985,152 square feet, I end up getting an equivalent amount of rain of 0.4 feet. And then if I want to convert that to inches, I multiply what you've got 12 inches in 1 foot. That ends up being 4.8 inches. So my equivalent rainfall is 4.8 inches. Now, a quick word on volume. When we talk about volume of flow, this is a big number. When we talk about 78,390,000 cubic feet, a lot of times volume for water projects will be expressed in acre feet. And so think of that volume, because acres is an area times a depth, feet. Think of that, 1 acre foot would be an acre of land surface inundated by 1 foot. So if we wanted to convert 78,390,000 cubic feet to acre feet, all we would do is divide by 43,580, which is the value of square feet in an acre. And so we wanted to do this real quick. We could look and say, okay, well, I've got volume in acre feet. So I've got 78,390,000 cubic feet divided by 43,560, I think it is, square feet in 1 acre, okay, per acre. That gives me, I have to check that units. Somehow that 43,560 doesn't sound right, but I'm just going to go with it. So 78,390, enter in that as a volume, divide that by 43,560. We end up having that being equivalent to 1,799.6 acre feet for my volume.